Hello everyone, welcome to my talk. The topic I'm talking today is mPuppet, a declarative subset of Puppet configuration language. So nowadays, large-scale data center typically consist of hundreds or thousands of machines, and each machine consists of many softwares, for example, databases, web servers, or middleware. And manually configuring such a big system is impractical, and hand coding script is difficult to manage and also error-prone. So misconfigurations can potentially infect many users and cause big loss. So in 2011 April, the failure of Amazon EC2 lost many days, and some customers lost data. And recently, 4 hours outrage is estimated to cost Amazon customers 150 to 160 million loss. So there are a wide range of configuration frameworks developed for configuration to improve the automation of configurations, and such frameworks in general share a mix of declarative and imperative features. As for imperative aspect, so developers just need to write a script and make sure that all the command run in the right order. Nothing goes wrong in the final configurations. So on the other hand, a declarative configuration framework has its own benefit, because developer will be able to write their desired configurations in some high-level way, and the realization of configurations will be in charge by the framework. So such frameworks, for example, there are Chef, CD Engine, Ensemble, and Puppet. So Puppet is a widely used framework in industry. So it consists several aiding software, for example, databases, and also repository and models. And also it has a self-contained Puppet language. So Puppet is designed and implemented in an ad hoc fashion. So because this ad hoc fashion in implementation, so if there are some configuration errors happened, so it's very hard to understand what the reason of the mistake. So our aim of the research is formalize the semantic of configuration language as the first step for further analysis tools. So let's have a look of an example in Puppet language. So a program in Puppet is called manifest, and the output is called catalog. So in this manifest, first a class is defined, then a second class inherits the first class, and then a node is defined. So node in Puppet is corresponding a machine in the data center. So in the first class, case is a statement, is a conditional statement. It matches the control expression to one of the branches. If it matches, so the branch will be selected. Then in the second class, package is a resource, is a specific construct in Puppet. So resource describe the configuration tasks. Basically, we need to configure the machine. So in this package, there are some attributes and values. And in node, include SSH is declaration of the class. So in the end, with the compiled catalog will be the evaluate the resource values. And let's have a overview of Puppet. So Puppet is based on client-server architecture. And so there is one Puppet server called Puppet Master. So all the manifests will be collected in the server, compiled as one manifest. After compilation, it becomes catalog. So a node, nodes are machines configured using Puppet. So it's called Puppet agent. So a Puppet agent or a node send a request to the server, and master will compile the manifest for them, get the catalog, and send catalog to the server, to the node. And at the agent part, the catalog will deployed, and then the machine will be configured. So we can see that in this process, compilation only happen in the server side, and the deployment of configuration is only happened on the agent side. So these two procedures are completely separate. So in our research, we only concentrate on the compilation stage. We are concerned that from manifest to catalog, this compilation stage process. And I want to specify some distinct aspect of Puppet language. This language is mostly declarative, because as I said, the resource is this distinct construct. So this language mainly describes a collection of resources. The other construct, for example, class or nodes or conditional statement, they are just doing some data control flow. And there are also some basic expression computation, and there's no other computation. So since its development in ad hoc fashion, and Puppet is continuously evolving, and this language is without formalism behind at all. So this language is also domain-specific language. It describes desired configuration data instead of performing configuration actions. And also there are class inheritance in this language. They are also different from the normal object-oriented concept, because class here is just a set of claim of resources. Inheritance has the functionality of passing the values to the attribute in the resources. So there is also no other computation. So let's have a closer look at the resource construct. So this is a resource called file. So file is a built-in resource type. And in the body, there's a user-defined name, and followed by a list of attribution value pairs. So these attributions are also predefined. So for define the semantic behavior of Puppet, we select a core subset of Puppet. And first of all, we formalize the abstract syntax. So the syntax consists of three main categories. There are expression, statement, and manifest. So expression consists of basic values and variables and expression operations. And then there are also data structure like hash, array, reference, and selector. So selector is also a case matching structure. So it's similar as case, but it can be used as a value. And in the statement, it consists of expressions, variable assignment, and all the conditional statement, and the resource, as I mentioned, and also the declare of a class. So is the statement include A. A is a class name. So manifest is corresponding to the whole, to a real manifest. It consists of out statement and the node definition, class definition, and define resource type definition. So all these definitions only can be made on the top level. So define resource type is user defines resource type. So it's beyond that built-in resource type. So we formalize the semantic of Puppet in small step operational semantic. For formalization, we have three main judgments on expression, statement, and manifest. They all evaluate based on some accelerated notions. So sigma is a variable environment. Kappa is a definition environment. So VC is a catalog. Alpha is scope. So N is a current node, which we will compile for the manifest for. So let's have a close look at the environment. So sigma variable environment defined as variable and its scope mapped to the variable's value. So definition environment kappa is from identifier to definition. So identifier is either a class name or a defined resource type name in the manifest to the definition. So definition consists of three main components. So for example, class definition is a component to record the content of a class. And the declare class, just to identify the status of class, is declared. And similarly, resource define is to store the content of a defined resource type. And for example, if a class is defined as the left-hand side, so when we evaluate this definition, so all the content in a class will be stored in this definition class define, and this class define will assign to the class name A. So B is the inherited parents B, so row is list of parameters, S is a statement. So at last, so VC is a catalog. So it will collect, record all the evaluated resource value in this environment. Finally, it will be the compile result. So you may notice that we have class and node and also whole manifest. So there's a different scope in Puppet language. So for example, in this manifest, the variable backup is defined at top level manifest. Then a class is defined, and then a node is defined. And in the node, there's a variable path is defined. Then the class SSH is declared. So when we compile this manifest, so the class declared in the node, it will has the same scope as the variable path. So it will get the value of a path because it's just a static scope. But for the variable, for the value of backup, variable backup, it's in the top scope. So in the runtime, it will get this value of backup. So you see that in Puppet, there are both static and dynamic scope behavior. So we want to formalize this scope behavior. First of all, we formalized all the scope in the Puppet, and the double colon is top scope corresponding to manifest. Then double colon ND is a node level. Double colon A is a class scope, and A is a class name. So alpha def is a defined resource type level. And then how we use the scope in the operational semantic. So you see in the judgment, the scope alpha is on the beyond the transition, which means when we evaluate a statement S, it will be under the scope alpha. So how will we get the scope in the evaluation? We also defined a runtime statement called scope alpha S. So scope is a keyword, alpha is a scope, any scope, statement is S. It also means that S is only evaluated under alpha. So we'll see the real evaluation rules. When a node sends a request to the master, so the server will compare the name N to the node name Q in the manifest. If they match to each other, the first rule will employed, and then you see the definition node QS will become to a scope runtime scope statement. We stored a statement in this scope statement, and the scope in front of statement S is double colon ND. If this N and Q don't match, so we will skip this node definition and continue to evaluate later statement. And when we evaluate a class definition, so we will store the class content in the kappa environment. So the class name A will assign a class define, and class define has 3 parameters. B is the parents, row parameters, as a statement. So then the definition becomes skip. And when a class is declared, it's use the statement include A. We will first look up the kappa environment, and we see that class A is already defined. Then we'll change the status to declared class, and we'll take the content in class define into the scope runtime statement. So we also similarly will put double colon A as the scope in front of S, because double colon A is the scope, is the class scope for the statement. And how we evaluate the scope statement? So if there is a scope statement under some current scope alpha prime, we will propagate this evaluation to the evaluation under alpha. This alpha is in front of statement alpha, which exactly is what we want. So we evaluate alpha only under the scope for S. And the last rule shows that how we really use the scope in the variable environment. So when we want to assign a value of a variable, we first look at the current scope in the environment, sigma environment. If it's not in that environment under alpha scope, we'll go to the immediate upper scope, which is defined by the relation parent of. So this relation between the scopes are instinct in the Puppet language. For example, note is a parent of is an upper scope of class, and the top scope is a upper scope of note, and similar as for the inheritance relation. So in this way, we can go the immediately upper scope of current scope, so that we can find the value of these variables. This is runtime scope behavior. So besides the operational semantic we defined, we also defined two basic meta theory for the operational semantic. So first is determinism, which means that all the evaluation relations of mPuppet are deterministic, which means if we have a statement to evaluate or expression, so we have only one choice in the set of rules to evaluate a statement or expression. So the second theory is monotonicity, which means that all the environment we have they are only increasing in the size in the size along the procedure of evaluation. Catalog environment is the most important one for us for this property, because it's only if it's only increasing, it can guarantee the declarative property of mPuppet language, which implies that what we defined, what resource we defined, we have in the manifest, we will have them after the compilation in the catalog. And besides the formalization of semantic, we also did implementations. I want to mention we used a test-driven deployment approach. We designed the test set first. We designed 78 manifest and test on Puppet and see their semantic behaviors. And then we define our semantic to model the semantic behavior of real Puppet. So we try to cover as much as the behavior of real Puppet. So then we implement a prototype of parser and an interpreter based on the semantic rules. And the source code is available on GitHub page. So the evaluation for the constructed 78 test, 52 passed both mPuppet and real Puppet, and they get same result. And the 26 test contains some unsupported features where mPuppet have not yet, and so they didn't pass mPuppet. Besides the constructed test, we also test some Puppet their own test suite. There are only 48 tests we found, but this test suite is also quite outdated. So out of 5 of them already don't pass the new version Puppet 4.8. So the rest of them, 20 passed mPuppet. The others, there are some features mPuppet does not support. And I also want to mention some important unsupported feature we haven't modeled. For example, resource extensions and overriding, or resource collectors or visual resources. And for the resource extension or overriding, they basically add new attribute in a resource or remove attribute, which means it will change the resource in the manifest. So it will against the declarative property of mPuppet. So that's why at this time, we still choose not to model this feature, because we want to have this declarative property in first hand. And also this behavior will also change the environment. It will require some more complex operation on the environment. And similarly for collectors and visual resource, they're doing some collection and update or grouping the resources. They'll change the order of evaluation of the resource. So it will also need some operation on the environment. So, and even Puppet document don't recommend to use these features. They say that you have to use with extreme care. So which means it's very easy to have some unexpected failure if you use them without care. So relate and future work. So I'm now doing defining provenance based on the formalization of mPuppet to analyze configuration failures in system. And we can also formalize the more features of Puppet, like some unsupported features. And furthermore, we can also add tabs in mPuppet to facilitate an analysis of Puppet manifest. And also, there was a tool last year proposed in the PLDI, which is also based on Puppet, but its analysis only in the deployment stage for the determinism result of the deployment of configuration. So they covered some semantics of Puppet, but we covered more bigger side of semantic or a full side, include some more main construct. They may use all semantic for their tools. Conclusion, configuration language are being widely adopted, but their semantic are not well understood. And we identify a core subset of Puppet language as mPuppet and formalize its small step operational semantic, implement and test a prototype parser and interpreter for mPuppet. So our work is the fourth step towards the further tools analysis for declarative configuration languages. So the full technique report and with the whole set of semantic rules is available on Archive. Thank you.
So the way you do, there seems to be a chain of scopes, of parent scopes at runtime when you're looking up local variables, which sounds a lot like some of JavaScript's evaluation semantics. Is that similar, or are there major differences between those two?
You mean Java?
JavaScript.
Oh, okay. I don't know so much about
Okay,
it.
that's fine.
Sorry.
Thanks. I was curious mostly about the future work, since it seems that the semantics of Puppet are very complicated, and I mean, are you maybe also thinking to somehow suggest to the developers some way to streamline them, or maybe highlight some corner cases when strange things happen that allegedly may be complicated, and maybe propose fixes based on your formalism? Are you also planning to do that?
I'm not sure what fixing means, because in Puppet, because they development in an ad hoc way, and there are some errors, they don't even report their errors, so they just don't deal with this case. So, so I think, for example, they just ignore the errors. They're still compiling, but they just behavior is very strange. So I think one thing is that, or we just formalize as how Puppet works, or we just formalize something we want how it works, something like this. Yeah, there's some corner case. I think a lot of corner case, and I think they just ignore, like just something like nothing happens.
I have one quick question. I'm not very familiar with these configuration languages. Can you tell me if they're very performance critical? Because if they're not performance critical, then it would make a lot of sense of writing those in a theorem proof and then extracting the code to some slow high-level language. So do people care about how fast Puppet runs?
Oh. I think I Okay, I'm not quite sure about how fast it is, but I think it's run always on a very big set of data, because it's it's used by some companies, and I think the configuration file should be big.
How big?
Yeah, and I think the compilation is one stage, the deployment is another stage. I think both of them really contribute to the efficiency of the configuration. So I don't know I don't have the real information about this efficiency thing. Yeah.
Thank you.
Let's thank her again.
Thank you.